Okay, so what I have here laid out is the complete kit of parts required to build DigitalBird camera slider. It comes first and foremost, I guess, with the main control board, which is an ESP32 control board here, pre-programmed for you with a stepper driver, a single stepper driver on this board, two stepper drivers for the pan tilt head, but this one is the single. Next up, we have our Nextion TFT color touch display. It's a 2.8 inch and it sits in the control box with our second ESP32 control board, which is a feather board with all the pins pulled out as required for the wireless controller. Inside that kit of parts, you should also find a new feature, which is a battery charging board. The one on the feather not being really up to the job. We have a wiring harness for the Nextion with a 5-volt boost and a switch harness. Okay, now the Nextion parts, if you like, are covered in a separate video. What we're going to concentrate on in this video is actually building the slider itself. And so what we're left with here are the other mechanical parts that are required for the slider. We have our 500mm long V-slot aluminium rail. Put that out of the way. We have 4 mini gantry plates with Delrin wheels. I'm not going to move these, I'll leave them where they are. We have our NEMA 17 stepper motor, complete with the tooth cog, 20-tooth cog I think it is, on the top of here. And another new feature is we have a vibration damper on that stepper, which is there mounted for you, ready to go. I'm not going to name them all, but we have a full set of all the screws, nuts, bolts and plastic inserts required to build the slider in a pack here. We have a number, I think it's 22 or more neodymium magnets, which we'll go through where they all go. We have a shutter release cable or shutter release port, which plugs into the main board. Another set of pulleys, idler pulleys, with accompanying axles and washers as required. This is for the stepper motor. This is stepper motor cable to the board. This is our AS5600 board, complete with a small magnet, which I'll go through later. It's our encoder. Over here we have our limit switch, nice little board limit switch. We have our power cable power switch, and I've put in the same bag a small bubble level. We have our DigitalBird battery harness for the Sony MP style batteries. Power cable which runs the length of the rail. Some neoprene rubber for the feet. 10mm GT2 timing belt. And a 120mm Swiss plate for the bottom of the slider, for mounting the slider to the tripod. So let's get on with the build. Okay, so before we can start screwing things together, the first thing we have to do is prepare these plastic parts with these small brass plastics inserts. And the way I do that is with a small kitchen blowtorch, a flat blade of some description. This one's for icing cakes, but it could be a chisel or anything of that description. I need an M5 bolt to just hold onto it while it gets heated, and a small sponge with some water in it just to cool things off at the end. And the process is very simple. Take our part, this is what we're aiming for here. I have another one to put here, another to put here. So I take my brass insert, give it a small turn onto the screw, just enough to make it catch. Okay, I'll turn on my blowtorch, being careful it doesn't point at any plastic. Heat up the brass insert. Okay. Place it in the hole and press down until it sinks just above the surface. Take out the screw and use the flat blade to just push it down and keep it level with the top surface. Then use a sponge to just squeeze some water over there and just cool the whole thing off. Okay, we've got quite a few of these to do, so I'll not bore you by showing you them all. It's the same process with these, which are quarter inserts. And for example, I think, yeah. So here we have a hole for a quarter insert on the side of the motor block. And I don't have a screw the right size for that, so I'm just going to use a pair of pliers to hold on. Just heat this up. It's a little bit heavier, these parts require a little bit more heating. Place it in the hole on the side, feel it sinking down. Press it till it's almost all the way down. Take my flat blade and press it down the rest of the way until it's flat. Take my sponge, squeeze some water on there to cool it down. And that's all there is to it. We'll come back when I've done the rest of them. So with that job done, here are all the parts that require the brass inserts. In our motor block here, we have one brass insert on the flat face on the inside. We have a quarter on the side for auxiliary, and on the base, in the smallest hole, we have another one to take the foot. On the control box, we have 3 on the flat face at the back. We have 1 underneath to take a foot, and that's it for the control box. On the bottom carriage, there's 1 that's going to fix our belt in the bottom carriage. On our battery plates, on this one with the large square hole cut for our boards, there's no inserts apart from the one on the bottom for the foot. And on the other battery, there are 2. And they're diagonally opposite each other like that, and 1 for the foot. These 2 orange parts here are our rail end connectors, and in the bottom we have a quarter, that's one of those ones, insert in the bottom of each, and those are so we can connect the tripod to the slider and hold it up either at an angle or between 2 tripods. And that's all there is to the inserts. There will be 1 left over in your kit, and this is for mounting the camera as a regular adapter. Okay, so put that to one side, and that'll be for later on. Next step. Okay, for the next part of our build, we're going to be looking at this encoder housing, which goes onto the back of our NEMA 17 stepper, like so. And it does this just with these 2 small magnets inside here. Now I've already glued them into this because I'm just reusing this from a previous model. You take 2 of the small magnets, it doesn't matter which way around they go in this case, it does in others, so don't rush ahead and put all the magnets in. They go into the small holes in the housing here, like this, and they just allow that to snap to the back of the NEMA 17, like so. Now you see there's a small window in the center of this, and if we take out our AS5600 encoder, you will find it comes with the cable and everything ready, and a small magnet as well inside. Now this is a special magnet because it's diametrically magnetized. That is, in these magnets here, the north and south poles are on the faces, north on one side, south on the other. But with a diametrically magnetized magnet, it's split across the face. So one side is the North Pole and the other side of the face is the South Pole. You can see the effect that that has. Unfortunately, these little boards, if you're buying them outside of the kit, often come with the wrong kind of magnet. They're not diametrically magnetized, and they will completely screw up the whole project, because this won't work unless it's a diametrically magnetized magnet. And you can see that magnet, these are the ones that have come with faulty kits, and you shouldn't be able to do that with a magnet. This one is correct, and it does that because it's diametrically magnetized. You find that I can't make that magnet sit on top of there on the stack because of the poles. The correct magnet, if you put it on top of a stack like that, will happily sit at 90 degrees because the pole is the right way around. Anyway, your kits, if you come supplied, will come with the correct magnet. If you buy it yourself from somewhere else, chances are it will have the wrong kind of magnet and nothing will work. Okay, so the kit comes with the correct magnet, diametrically magnetized, and that little magnet just gets dropped onto the back of the stepper, and you find it goes in there and sits flat. And as the stepper turns, that magnet turns, and the AS5600 chip here reads the position of that magnet very accurately down the I2C port. Okay, so we take our AS5600 board, put the cable down through here, make sure the chip is facing down through the small window. And just press that in. Okay, like so, and you can see the chip through here. Take your stepper motor and your stepper motor cable that comes with the kit and find the right end. Put it into the stepper like so. So now this cable comes through this window and this cable lies flat, and the two should just come together nicely and clip on. Okay, then we take our encoder cover, and that should just snap on the back like so. I'll not screw it on this now, but there are two holes for the small M1 screws where you can hold that in place completely. And that's the casing part for the encoder, all ready to go with the cables. Put that to one side. Okay, so we're now ready to install our motor into the motor block. The square slot under here is for the cables to go through, and the motor goes through here on the round. Take your motor, put the cables through first. Bring them all the way through. Make sure the cables aren't trapped. And there are two holes here for those M3 50mm long bolts. And these go through and into the vibration damper on the other side of the motor. Like so. Okay, so with that done, we can now bring in our center section, which is the one for the control end, has a square hole in the side of it ready for the switch. And if we look at the back of this casing, there are three holes here and which match the three holes in the center divide. Center divide goes on like this, and we take these three low profile 50mm long bolts, and one for each of these holes, and we can just push these through here into that center divide like so. Okay, so that's ready. For our next step, which is to install our pulleys. Find the pulleys. So you have a bag of pulleys here with some washers and the axles. So we need two pulleys. Yours will all be smooth pulleys. For the purposes of this video, I've only got these, but in your pack they'll all be smooth because that's what they should be. So take an axle, put it through, and what I'm doing is putting 3 washers on the bottom and 2 on the top for each one, and it should go into this hole here, pulley in each one, like so. Now you may need to clean out the holes in this plastic to make them fit that easily, but that's you pretty much ready for that. Keep these aside for the battery end. On the top we have 2 washers. It's just the way it worked out with the dimensions. And these just stop the pulleys from moving too far back and forward. Okay, so with that ready assembled, put that to one side at the moment, and we're going to do some preparation work on our timing belts. Now in the kit you'll find a roll of GT2 timing belt, 10mm wide, like this. And the first thing to do is cut a length exactly 52mm long. Okay, so cut off a length 52mm long and put that to one side. That's going to be for the battery end of the slider. We don't need to worry about that just yet. What you're left with is a long piece of belt, a longer piece at least than the last piece you just cut. And you should have printed off these belt keepers, and 3 of them are required. And you can see that they have a serration inside there to take the belt, like so. Capture the belt like that. And a little keeper which snaps on top. So with the longer piece of belt, fix one of these keepers on there. Now, because the belt is quite resistant to screws going in, generally I use a very fine drill and just drill through and right through the belt as well. And then take one of these very small M1 screws, okay, and put it through that hole there and right through the belt. I'll not do it for the video, but there you go. On the other side there's this little hole for a magnet which we'll deal with later. So what you should have is your longer length of belt ready with one of these on the end of it. Don't worry about the magnet just yet. And the reason we need that at this point in time is we're going to have to feed that belt through all this assembly before we can put it together. Okay, put these out of the way just now for the next time. The other end of this belt doesn't need one of these, okay? And we'll cut it to length later. Okay, so next we're ready to prepare our 500mm long V-slot aluminium rail. So we need the 2 rail end keepers. The one for the control box side has a slot for the limit switch, the other one for the battery end doesn't. But before we put those on, we need to take our power cable, which runs the length of the rail, identifiable by the 2 red connectors on the ends. Okay, and what we need to do is the hole down the center of the rail, we run our power cable all the way from one end and let it pop out the other. Okay, like so. So we take our end connector, which has got the slot, and this cable goes through the oval hole here. So it's worth just pushing these through. The rail's going to rest on top of that shelf. It's showing this very well. So this goes through here. It should just pop out, and we can do the same on the other end in preparation for screwing it together. Make sure it goes through and pops out here. Okay, then we take these 20mm low profile bolts, and we're going to screw these connectors to the rail. The rail is tapped for M5. Okay, so this is our control end with the slot, and into that slot we can now put our small board limit switch, which will come in the kit like this with the cable on the yellow end. And basically the board goes into that slot there, and that just presses in like so. And you can see the limit working on that end. Okay, taking a step backwards, I completely forgot that before you can put this end rail on, you have to put your mini gantries on, otherwise you can't get them on the track. Now, if we take a look at these mini gantries, there are 4 Dowron wheels on each, and you'll notice that there are hexagonal bases on 2 of them and plain round ones on the other 2. And the idea is that these are off axis with the nuts, with the bolts behind. So by turning those with a spanner, you can adjust the amount of distance between the 2 wheels, and that allows you to allow for smooth running on the track. So what you want to do is get them so that they're not so tight that they stop the gantry from running, but they're not so loose that you get a lot of rock when you move them between these 4 wheels. Okay, so these were on previously, so they've already been adjusted, hopefully. So we need 2 of those on the top and another 2 on the bottom. I like to keep these going the same way, so if I have to adjust them, they're all working the same way. That one could do with some adjustment. And this one again. See, this one's rocking a little bit too much for my liking, and I'll adjust this later to bring this wheel a bit closer to stop that rocking. Okay, so with the 4 mini gantry plates on the rail, you can now install this end keeper onto the end of here. Okay, so coming back to our motor block, I was a bit premature putting these on because it's easier to put them on a bit later. Just put the spindles in with the 3 washers down. Now we take our longer belt, which is like this one, with the 1 plastic end, the other end has no plastic on it. Like so. On the second pulley, put the pulley on here. And drop it down like so. Okay, so plastic end at the top. This end runs free at the moment. Next we can take our little switch harness, okay, which is a little rocker switch like so, and square hole in the end here. We can feed the cable through that and up the center. Take our switch and just press it in like so. Let that run up in the center. Take your rail and prop it up on something at the battery end, like so. Take this end, place it on here, and it should just easily snap into place like that. Okay, don't worry about the cables at the moment. This bit of a tangle. Your belt needs to go down through, there's a slot in the bottom here, and pop out on the underside of the rail, like so. Just let that pull through. Okay. Okay, so it should look like that. Now you can drop your 2 washers on the top of your pulleys. 2 on each on this side, 3 on the other side. Like so. Now we should be ready to install our control box. Okay, so before we install the control box, make sure you have one of these 30mm long low profile bolts ready. And we already have our longer bolts through this center section. So there's a slot here in the bottom for cables to come through, and there are 2 holes here for the cables to come through. Your power cable is going to come through this hole here, your switch cable is going to come through this hole, and your encoder and your cable from your stepper motor are going to come through the slot in the bottom. So we put these cables through first. First of all, our encoder and our stepper motor cables, and they come out like so. Our power cable, no tangles, is coming up through this hole. Our limit switch is coming up through the slot, like so, and our switch cable, switch harness cable, is coming up through the left-hand hole. In the center, like so. Okay, and then this simply should come together. Okay, so if we're convinced everything is through and that these are all level, we can take our 30mm bolt and place it through this hole here in the casing. And that can just be put in, not over tight, just cinch it and no more. And that should hold it all together long enough for us to turn the whole thing over and put through those 3 bolts here. Don't over tighten them, just cinch them. Then just check all around at the seam that everything is closed properly, nothing's trapped where it shouldn't be. If you look in the top, our belt is going to come through over like so, and on the underside our belt comes through this hole under here. Okay, and that's the control end. Okay, so with the rail complete here and with our gantry plates in place, we can just move that out of the side a moment. Oops. And have a look at 2 battery boxes. Okay, for this end. Now you can see that one of the battery boxes has a square hole cut in it, and if you look at the battery harness that's supplied with the kit, DigitalBird battery harness, take that out. There are 2 battery prong boards and a link board in the middle, and that little link board needs to go into here. Okay, now you should find that one of these typically is longer than the other. The short one goes into the one on this side, and the long one will go on the other side. So what we need to do is take our board, and with the prongs, with the wires at the top, they should slide into there. Incidentally, you can file away the edge of these boards just to make them easier to fit into here. They file quite easily. There's nothing close to the edge to be destroyed by that, and they should just fit in and slot down as far as they'll go. And then you can see on the other side here that the prongs are now showing ready to receive the battery going in there. Okay, on the battery side of these, you can see that there are 4 little lugs or tabs here that accept the battery as it slides in. Now, those aren't printed with the part. You print those separately. And the idea being that they're stronger if they're printed separately, and if you break them off, you can just pull the tab out and add another tab in its place. So the little tabs here, typically you'll find them easier to go into the slots. See, there's one out of the slot here. If you just, the side that's going into the slot, just take the corners off it, take a pair of tweezers and your tab, offer it up to the slot like so, and just press it home. And I don't glue them. As I say, if it breaks off, I break a tab or whatever, I can just print another one and put another one in. Also on this side, because we have the screws going through that side, this tab will get in the way. So it's better to leave that one out closest to the hole until after you've assembled the whole thing. That's just why that one is not currently in place when we left it. I'll have to pull it out. There we go. I won't lie to you, this is probably the fiddliest part of the build, and I've had several attempts at working out a system to how this goes together. So we have our power cable coming in here into the small board, and we have the 4 cables from that small board coming out and into this slot here, and I've super glued those 4 cables in, okay? They come over and into this one. So this is your starting point. Now it's important before you go much further that you make sure that the holes, that those 2 holes here and those 2 holes here for the axles, for the idler pulleys, that they accept those spindles right up front, because you don't want to be fighting with that later on when you try and put the 2 parts together. So make sure, if they're not a perfect fit or you can't get them in, use a 5mm drill and just ream out the holes to make sure that they go in easily. We don't want them too slack, but we don't want them so tight that we're having trouble getting the parts together, because it's fiddly enough. So we take our 2 axles, we drop them into this half with the small board, and we take 2 small bearings, so small washers rather, over each axle. Okay, so before we put this piece in, it's worth taking our 52mm long piece of GT2 timing belt and running it through the bottom one with the toothed face outwards, like so, around here, and just around here like that. Oh, tuck it in somewhere. There you go. Then we take one of our idler pulleys, and again these will be smooth. Put the pulley over the top and the belt, and the belt, and pull these through. Then take 2 washers, place them on top as spacers. Like so. Now in this side there's a slot, and our 2 cables here need to go down into that slot and slip through. So that can be fiddly. And then the square end of this sandwich centerpiece goes into the square hole in the side of the rod end, and it should just be a press fit. Okay. So we've got our belt through. We can check that our power cable is properly pulled through, not going to jam on anything. All we need to do now is bring this half down, make sure these cables aren't trapped, and then bring this half over and make it connect. Now the bottom of this should be flush with here, and they should just come together, but this cable's starting to pop out, stopping it. Oh, it's stopping it. You have my sympathies for putting you through this. There you go. And you should feel the idler pulley axles connect with the top, and this should be in all the way. So when you're happy they're connected, hold the two together and flip the whole slider over to reveal two holes in this side. Then take two 30mm bolts, put one through here, and with the right, and just tighten it up. Not too tight, just enough to cinch. Okay, so with those correctly fastened together, it just remains, remember that last little tab, which we couldn't put in because the screw wouldn't fit past it. We can now put that tab in there. That should fit in nicely. Okay, so we don't have any ends on these, on this side of the slider yet, on the belt. So we need another two of these end keepers, and it's exactly the same process as before. We take that, make it flush with the end, and we take our second part, press it over to just capture the belt end. If you don't drill a hole through the belt, you find that you can't get the screw to go through it because it just keeps bouncing off the rubber. I find it easier to use a flat screwdriver on these little screws, you know, a little watchmaker's flat end. It's easier than a star end, even though they're star screws. It just gets more bite on the screw when you're putting it in. And that goes down through and into the belt and through into the plastic behind. Okay, so next up on our to-do list are to install or finish off these carriages. We have a top carriage here which needs to be printed at 100% fill. And the reason for that is the screw that holds our camera or our pan tilt head or whatever goes through here. And if this isn't 100% fill, I've discovered that as you tighten payloads onto this, before too long you find that it compresses the fill and this starts to come loose and wobble around and press through up through the carriage. So print the top one at 100% fill. The bottom one you can get away with less, about 35% fill, because it doesn't have any of these problems. And remember, it's not the actual plastic that's carrying the weight on the tripods, because these screws go through into here and into these solid aluminium gantry plates. So it's the gantry plates that carry all the load, not the plastic really. Also, we have a locking mechanism on the top one here, which needs, it's helped by the fact that this is 100%. The locking mechanism itself is in two parts. There's the main body of the lock here. Well, you can see that. And there's the button that we use to activate the lock. Now, it's a magnetic lock. We have a small magnet built inside here at the bottom. I think I've already installed that one. You can probably see it just in there. And we have another one in here in the the bottom carriage, a magnet gets super glued into here as well. Okay, now if we look at the carriage, sorry, if we look at the lock mechanism, the small square hole is for this button, which will get glued in later, okay, like so. That's nearer the top, so that goes this way into here, and you can see it catches on that top magnet, and the idea is you can pull it back and forward between the two magnets to lock the two carriages together. And this is simply just so that if we want to move the slider around anywhere on a tripod, it's just nice to be able to lock it and not have the camera and everything sliding back and forward along the carriage. Now the top screw here, both of these screws, you notice that they're silver edged, these ones, because they're just 10mm low profile bolts like these, but I put them into maybe an electric screwdriver chuck, and then just put a file against the edge and file them down so that the hole is, the head is small enough in diameter to fit into this hole here between the carriages. So you require two filed down like that. They are just 10mm nuts, like bolts like this. And the top one, the one closest to the square hole, should be screwed all the way in. The bottom one should be about 4.2mm, 4.3 if to be exact, between the top of the screw here and the start of the plastic. It should be 4.3, 4.2, 4.3mm. And that's just so that it's just the spacing that works out, so that touches the magnet when it comes down. So with that set up, that can go into there ready to go. This button then gets glued on. Now once you glue this button on, you can't adjust anything else. So make sure this is sliding in and out smoothly, probably more smoothly than I've got it at the moment, before you start. Okay. Now, as I mentioned, we have these 4 holes here which use 10mm bolts to fix to the gantry plates, but the center one is for our quarter, and we use one of these quarter camera fixings, and you can see the shape, and what we do is we just put that into the center. Screw it in, and once it reaches the flat, you can find you should be able to just push it down, and that will be held in place because that will rest against the top of the gantry plate, so it won't be able to move from that position. And then we have our quarter. Okay, I keep saying quarter, it's actually an 1/8 thread on here. To make it a quarter, there is an adapter like this, which can simply be glued on there, not glued, screwed on there. Okay, and then we can fit a quarter mount for the pan tilt head onto that, but it gives us the option of fitting the camera directly if we just use a 1/8 screw as a starting point. The large round hole here is for our little spirit bubble, which comes in the kit. And remember, this will have been printed that way down, so the plastic around this hole here may be slightly because of elephant's foot, it may be slightly larger, so it's worth just taking a knife and just paring that first edge in there, and once that's done, you should find that your spirit bubble just fits in there and presses down like so. Okay. Now, if we look on the underside, there are 2 holes here for magnets, which we're not going to put in just at the moment, but it's the same kind of magnets that come in the stack, the 8mm magnets. Now, it's important that these T-shaped belt connectors here on the end, these should fit nice and, not loosely, but comfortably into this here, and just snap down like so. And there will be a magnet holding that in place. Okay. Now I've got to answer the door. Yeah, so these can print quite roughly, so it is worth, you know, going around the sides with a file and just making sure that they are level. They're printed solid, so there's plenty of scope for just smoothing them off. And also on those edges here can often be quite rough, and it's worth just leveling these off. You know, where it comes to a corner, quite often the 3D printer doesn't handle the corner terribly accurately. And as I say, it should just drop in like that. Okay, so as regards the ends of these, you have another 8th magnet, and these magnets will just go into here with a little bit of super glue, and another one into here, again with a little bit of super glue. Now it's very important that you make absolutely sure when you put these in that your belt connectors match and attract each other, otherwise your magnet is going to have the opposite effect to that intended. It's going to push the belt out. Okay, I'm not going to say any more on that. I think that's pretty much all there is to that. It says it fits on here like so. You will have the magnets in place. That'll come up. And with these in place, that'll connect. And this then is connected to the gantry plates with 4 of these low profile bolts, which just go through here. But I'm not going to put them in just now because I've still got this belt end to do. So once I've done it, that belt end will be in here and this belt end will be in here, and that's all there is to the top one. With the bottom plate, it should have the brass insert on here, and if you can imagine, that's the way your bottom plate goes on here, and your hole aligns with your switch, your locking switch. There will be one odd bolt in the kit, which is about 14 millimeters long, approximately. And that one odd low profile bolt is for use here on the bottom gantry plate, and that just screws in there. And only 3 of our belt ends have these magnetic keepers. The last one is left bare, like so. And the idea is that that comes in, get it the right way around. Your belt will come up through here and lie flat against here, and then all you'll do is, and then you'll be able to pull the belt to get the tension you want across all the belts, and then just tighten up that bolt to prevent that belt from coming loose again. And then your Swiss plate will come across the bottom of that as well. You'll be able to chop that belt when you get that far. Other than that, I don't think there's anything else to do to this except put the magnet in this end for receiving that connector for the bottom one here, and that one will go on here this way around. Okay, so I'll put that together now and I'll show you the end result of that. Okay, so I've glued my magnets in, making sure that they attract the magnets in the top carriage, And then I can just take this, snap it in there on that side, and take this one from this side, and snap that one in there. Okay, and then that's ready now just to go onto the gantry plates, like so. And we can use 4 of these 10mm low profile bolts into here. They should line up with the gantry plate. And that's the top carriage in place. Now for the bottom carriage, start by placing your belt with no end on it through the hole. Take the belt from this end, just like the top, let it drop in there, and place that underneath here. It snaps into place like so. Then we can turn the whole thing over. Belt mostly tight at the moment. Now, in the kit, I provide 120mm Swiss plate. It comes with another one of these 1/8 screw threads. We're not using that. You can put that to one side or use it on another project. The head was just too small to use on this project. It also comes with these 2 anti-slip nuts. Generally I take them out, but that's just my preference. If you can find a way of making them work, that's up to you. Okay, so this is going to go down on here. So what to do is to pull your belt until it's reasonably tight and give yourself a bit of extras to get hold of. And then we can cut the belt along here. If I've got anything to cut it with. Yeah, so I'm just going to leave a small... Okay, so I've cut this belt and left a little piece here. Okay, to install our Swiss plate, skip a hole here and put a 10mm bolt in the next one. Skip the middle hole and skip that one and put another 10 on the end. Take your gantry plate with the open side up towards you, place that on here and take a 50mm bolt. Pass that through into there. Okay, make sure it's centered. Take another 15, put it in here. This one goes into the slot in the Swiss plate. Okay, and that's our Swiss plate place. So now we can turn the whole thing over and we should see our carriages right like so at the moment. The noise is just the motor being turned. I won't do that when it's finished. So what we're left with is this little push button here, and if you're convinced that this is all working smoothly and connecting, you can simply put a little bit of super glue on here and install that button. Just watch you don't get it on any of the rest of the part. Otherwise you'll just glue your locking mechanism together. Yeah, make sure that that actually fits in that hole before you put the glue on it. on like that. Okay, and there's our locking mechanism. Right, next step. I suppose the next thing we should do is to just stabilize the whole thing, is get the feet on underneath, and that will give us some stability to the project. Now the feet have changed, largely through calls that using heavier cameras on the system caused, and also using the over-the-top pan tilt head caused quite a lot of pull and wobble on the slider. And the way I've gotten around that is I've developed new feet. And the problem is you want your feet to be neat and sit up here underneath these boxes at each end. But then when they swing out, they need to be long enough that they give enough support for the large lens or a heavy camera system going over. So to that end, I've altered the feet now, and they're now telescopic as well. So you get quite a substantial amount, and from experiment, it now carries much heavier payloads without that tilting going on. Okay, so there are 4 feet to do, and the feet all come now as 2 parts. So you have this part, and those two go together, like so. Okay, so in the kit now you will find you get a number of these long bolts, and they're stainless steel cap head bolts, and these should fit inside here. Now you may have to work this a bit because they have to slip in and out of these holes, the heads. So you put one through each. There are 2 sizes. The smaller feet at the battery end use the smaller screws in length. You can see these would be too big, and the bigger feet use the longer screws. I think one's 40 millimeters long, those ones, for the smaller ones, and the 60 millimeter ones are for the feet at the control end. So I'll just assemble this one so I can show you. So that should go through there. Now, you really want them to slide in and out of there without much effort, but not be too slack. So I've made the hole the right size, but inevitably the plastic shrinks holes. So what I would advise you to do is trim out the hole with a 5 millimeter drill bit, which I had lying around. Yeah, so just remount these holes with a 5 millimeter drill bit so that the bolt doesn't have to be threaded through that hole. Place your bolt back through now. It should go through and push in and pull through. Okay. Find another one, do the same thing. It's a bit stubborn going through this side. Push the head through first just to clear out that channel in there. Okay, so there's a little tab on here, and I've found that you may have to give that a little file down. It's a bit of an experiment just to get, you want just enough catch, but not so much catch when it connects in here that it makes it too hard to pull the thing apart. So put the two together like so. Don't over tighten or the bolt can come right through the plastic on this side, so just tighten it up until when it's in a closed position this bolt is inside here. Now if that's too tight coming apart, it's likely that you need to trim this latch here a little bit, just with a small file on both edges, just to make the connection a bit less fierce. There you go. Now, since printing this one, I've changed the design just a little bit, put a little tag on the top of there so that you can get your nail in if need be, if it's being stubborn, just to help pull that apart. So those are the small feet, and you'll get inside the kit a roll of self-adhesive neoprene rubber. You just place the foot down, cut the shape out on the part. There's the bigger foot here. And trim back, and then slice down where the join is here, and you have a foot that sits like that and can be telescoped away and click shut. You put an M5 10mm long low profile bolt through the hole here. And one thing to do is don't try and cut out this with a knife or anything. Just take your bolt, press it through the rubber, and when you tighten it down, it will naturally cut a nice neat hole through the neoprene for you, so you don't have to create a messy edge. Okay, so the other thing that needs to be done is we need to put a small magnet in here, because these magnets work with the magnets on the bottom of the slider. So now each of these holes that are left underneath next to the brass inserts need a small 8mm magnet inside it. Now, what's very important here is that the magnets all attract each other. So the magnet that goes in your foot needs to attract the magnet that goes into the bottom of the parts. You don't want them repelling, otherwise they won't do. So the idea is that the magnet will stall against whichever magnet at roughly 90 degrees. Okay. So I'll go ahead and install all those magnets, and I'll not make you watch that, and I'll show you the end result. Okay, so here's the slider, complete with the feet attached. And it makes a huge difference to the stability in that direction. It's not going to go anywhere, regardless of how heavy the lens is. So to fold up these new feet, you can just press these back in, and literally just flip them in like that. Flip them in, and there we go, ready for transportation. In terms of the locking mechanism, you slide the two carriages together, and that just latches down, and then the carriages won't move apart. Just remember to unlock it before you power up, because it will start to home by itself, and if the lock's on, it won't be able to move. Okay. The next step, before we go too much more over the electronics, is we have two cover plates. This one with the downstand is for the battery end, and this one is for the motor end. And before I cover up the inside of this with the control board, it's a good idea, because you might find that this one is a bit tight going in, that you can slacken off the bolt inside here while you can still reach it. This one, just slacken it off a little. And you may have to slacken off the back one on this side a little. And that'll just give a bit of give to get that in and connected all the way like that. Likewise with the battery one, if you slacken off that bolt a little, it should just slot in the top there. And then you can tighten up these bolts again against that. Likewise on this side. The only other thing I can think to mention at the moment is the belts. The belt tension should be as much that you shouldn't be able to lift it much more than that. Okay, and it should spring back to being tight. Next up is installing our DigitalBird mainboard. And this one is set out for the slider with the single stepper driver and the ESP32. Now, if we look inside our control box here, one thing I've done is the screw that goes through the back of the control box here, I've just used a little piece of, you know, the neoprene tape just to cover that screw, just to avoid, I mean, it is sunken in and it shouldn't touch anything on the back of the boards, but just in case, I've just put a little piece of that black neoprene over that screw just to prevent any contact. Your power cable here should run down inside this slot, and your switch cable comes down and runs inside the slot at the back here. So all the cables are arranged along the bottom. Now you can just put a piece of tape over that. I've got a hot glue gun, so I'm just going to hot glue the bottom of these cables in place. So the board goes in with the stepper driver with the heatsink on it to bottom left. Get rid of that. And it should just neatly fit home. Now, I know that from experience, better to put that side in first and then push down. Okay, and the 7.5 volt power input should align with that hole, and the ESP32 USB should align with the slot in here. Okay, now the cables are color coded except for these two, and this is the only place you can really go wrong, is the two 4 pins. Now, one of them is your stepper from your stepper motor, and the other one is from your AS5600's encoder. Now, easy way to find out which one is which is if you just release your encoder from the back here and pull, you'll see the encoder wire move. And what I've just done for safety is just color coded with a marker the side of that one, so I know that that's my encoder is marked red. So the encoder needs to go in here, and it's actually marked on the board encode. And that just simply plugs in here. The other white cable, the other white plug rather, is for the stepper driver itself, and that plugs in beside the stepper driver. It's worth making sure when you plug these in, just check that you're not pushing out the pins in these plugs as you go. It's a common fault with these. Sometimes, you know, if the crimp isn't properly home, when you plug it in, it can push the crimp back out. Okay, the yellow plug then goes to the yellow, which is your limit switch in here. The black is your power switch. Okay, and your power cable, the red one, goes into the red port here. So once you've got these in and you've checked that the crimps haven't been pushed out by the plugs, you can just push these wires in here just now. I don't screw these boards in, you know, they're fairly neat in the box, and there's going to be a cover on top anyway, so it's not going to go anywhere. So what we're left requiring is the shutter release cable, which comes in through that. I'll just find, yeah, you have the 2.5 jack for the shutter release, and that should have a blue or a purple if I've run out of blue. And that goes through this bottom hole here on the side. And the jack, it just presses in here into the side of there. And the blue cable comes over and goes into the blue socket. Okay, that's all the wiring done. So next we have our cover which looks like this, and our shelf for our controller. And it comes in two parts, and there's a hinge piece which is printed separately for ease of printing. And basically what happens is that piece there goes in. Yeah, like that. And what we're going to do is glue that in place and then use these small 2.5, I think they're 20mm long screws through the side of here in the case and into this hinge piece here. And we've got two of these, one for each side of the control box. So I'll just do that just now. Okay, now there's two holes here in this plate, and that's for, you've guessed it, another two of the 8mm magnets. Now it does matter north and south on this occasion, because on our control box, which we cover in another video, also has two magnets on the back here, and these need to attract the two magnets in the shelf, so it sits like so, okay, so that your control box just snaps on. So you need to make sure that the two magnets that you put in your control box align with the two magnets so that they attract on here, and we'll put these in. Okay, so with those two magnets in, attracting my control box, the control box can sit on top of there and be held in place by the magnets. On the back of this, there's a place for another magnet here, and this should attract the magnet here inside on the side of the control box. So all that remains to be done is this should go inside here quite neatly. Just take that screw out a little bit. Yeah, so just put these screws in until they're just before they come through. This goes into here. Snap shut. And then just screw these into the hinge piece. Okay. That lets that open up, close up. Our control panel can go on the side here. Make sure the lock's off. Put our battery in here. And we should see our slider start to home. And just watch and make sure that it connects with the limit switch properly. And then returns. Now you'll notice that that screw here sticks out a little bit too far. It's because these screws don't have a thread all the way up to the top, so it's impossible to get one that screws all the way correctly. But if you just turn this off just now, because your Swiss plate along the bottom here is also screwed tight against the belt, now that you've tensioned the belt and everything, you should find that you can take that screw out of there and the belt will still maintain its tension. So that now you've not lost that extra, centimetre, that when you switch it on, it will go further before it hits the limit switch. Okay, so if we turn on our controller and just do a little test, if I say that that's the in point, this is the out point, and I slide this along, to here, press out. Now that rubbing of the belt sound there, I've adjusted the parts now so that there's no connection there.